Why this video exists. It's not a product pitch for Arista EVPN, and it's not a generic AI writes Young stunt. The goal is to show how we build an NSO service model end-to-end, the same way many of us already work with Cursor, and prove it on live devices. You'll see the Cursor window, the interview, the mapping table, the package files, the MCP tool call, and the terminal, not a deck of bullet slides. If you've ever stalled on NSO package mechanics before your first automated create, this walkthrough is for you. First, how NSO works today with a service model. An operator does not paste EOS line by line. They create a service instance, a row in NSO CDB with a small set of parameters. NSO applies your Young model and XML config template, renders device configuration through the NED, and tracks lifecycle, create, read, update, delete. Change the service instance, commit, and the leaf updates. Delete the instance, and NSO removes what that service owns. That's the contract we're implementing on Arista Campus EVPN Symmetric IRB in this lab, but the pattern is vendor neutral. The normal way to get there, without Cursor, is familiar and slow. You study the validated design, sketch operator inputs, hand-write Young, and the tailf XML template, run NCSC compile, reload packages, dry run against netsim, fix NED path mistakes, and iterate until one create works. Weeks often pass before you trust the first delete. Most teams never get past step 1 because the syntax tax is so high. On screen now, the package tree under NCS run 6413, package metadata, makefile, Young under SRC, template under templates. That's the artifact NSO expects, whether you write it by hand or with an agent. What's different when everything is developed in Cursor with an AI agent? The division of labor shifts, but the engineering discipline does not. You still run the service interview. You still produce a mapping table, operator inputs on the left, template derivations on the right. You still validate dry run and sync to on-real netsim. The agent accelerates syntax, Young leaves, template paths, conditional branches, MCP registration, while you own semantics, scope, lifecycle, which knobs the operator turns, what stays a fabric constant. The demo surface is MCP in Cursor, set up Arista tenant subnet IRB service, intent, not RESTCONF trees. That's what the viewer should see on your screen recording, and that's what this video shows in the Cursor panes. Act 1 in the workspace, config in. We open Arista's validated campus symmetric IRB slice, an EOS fixture you can difference, not a slide. Campus VRF, VLAN 310, L2 and L3 VNI, Anycast gateway on the SVI. In Cursor we ask, which lines become operator inputs, which become template derivations, and which remain platform prereqs on the leaf. This is the same starting point as our BGP root reflector service on SR Linux, real config first, then what's the service? Act 2, the service interview, captured in INTERVIEW.md in the repo. Before Young, we lock scope. One instance equals one tenant subnet on one leaf. If the VRF is new on that leaf, the same commit also creates VRF, L3 VNI, and BGP EVPN VRF. Optional Act 0 is synthesize service on pasted config, then shrink the package in the interview. We don't pretend synthesis is finished on the first pass. Watch the Cursor chat, human decisions, agent drafts, that's the realistic walkthrough you'd show in a live demo. The hero artifact is the mapping table, MAPPING-SLIDE.md on screen, not the Young file. Operator inputs, device, VRF name, L3 VNI, router ID for route distinguisher, VLAN, virtual gateway, customer access port, service name. Derived in template, L2 VNI equals 10,000 plus VLAN, route targets, Anycast MAC, VRF first idempotency. Operators never hand-edit tailf XML. They review and approve this table once. That's the skill we're teaching. From the mapping table we build the package in Cursor. The Young stays minimal, 7 operator leaves plus the list key, everything repetitive lives in the XML template. On screen, VRF first conditionals, customer access port on Ethernet, denormalized road router ID, the same credibility pattern as our BGP/RR client service. Then compile, reload, dry run on Arista netsim, fix NED gaps. The editor view is the proof you're in the real workflow, not a sanitized slide. Act 4 is the product moment in Cursor. The agent calls set up Arista tenant subnet IRB service name, device, VRF, L3VNI, VLAN, gateway, customer interface. One MCP call maps to one RESTCONF put. NSO renders EOS and stores the instance in CDB. The viewer sees the tool invocation in the agent panel and the JSON result. That's the demo you'd normally screen record live. We prove it on the lab. Bulk deploy creates 5 tenants across 3 leaves, 15 instances, same model, same mapping table. The terminal shows RESTCONF puts and verification, 5 VRFs per leaf, L3VNI 5001 through 5, customer ports on Ethernet 101. Sync to against netsim confirms NSO's rendered config is accepted. Topology slides only where geography helps, the rest stays in Cursor and the shell. CRUD in one session, create, read CDB or show running config, delete through the service model, not a hand edit on the switch. A credible demo also names limits. Someone still validates the mapping table once. Synthesis bootstraps, this package needed human refinement. Bulk RESTCONF list on our lab NSO can timeout, per service tools work. Service models fit repeatable patterns, not one-off snowflakes. Takeaways. NSO service models today, CDB instance, template render, lifecycle. Traditional path, weeks of yarn and XML grind. Cursor path, interview, mapping table, agent syntax, MCP operator surface, with you in the driver's seat on screen. Teach the mapping table. Show Cursor. Show CRUD. Thanks for watching.